না, কিছু আর শুনতে পাচ্ছি না। Good morning, everyone. Sir George, Ma'am Anuradha.
Two things are infinite, the universe and human stupidity. And I am not sure about the universe, said by Sir Albert Einstein. With a desire to rekindle the passionate fire of deliberating upon various innovative ideas and to come up with the best amalgamation of various young minds whose sheer knowledge has the power to revolutionize the world. I, Aryan Manna, on behalf of Don Bosco School, Lilwa, welcome you all to the first ever online edition of Science Exhibition 22. It's a platform to put to test all the science and technology ideas which have slipped into one's mind. Who knows, the next Albert Einstein or Charles Darwin might be sitting amongst us. With the motto, Oceanus Cognitionis, the audience shall witness students discuss, structure, and restructure various science ideas, leaving them in amazement. We hope to see the best of brains engage in a healthy competition of brain and brawn. Prayer comes from the heart. It's a simple look towards heaven. It's a cry of recognition and of love, embracing both trial and joy. It's the nearest approach to God. It goes beyond our minds and touches the deepest recesses of our souls. It changes us from within. To invoke the divine blessings of the Almighty upon the occasion and on each participant, I would now invite our Father Rector, Reverend Father Thomas Gomes, to lead us into prayer.
My dear students, thank you for inviting me to lead you in prayer at the beginning and starting of your science exhibition. As I go into pray, it reminds me of Albert Einstein, who said, "Science without a religion is like a lame man without a crutch." It gave me such a deep insight that such a great man as Albert Einstein said about this, about God and religion. So it is rightful that at the beginning of this exhibition, we call God Almighty, who is a mystery to us till today. And we call upon Him to bless this exhibition of ours and to enlighten us more and more into science and religion. O Almighty God, every morning we call on you at the beginning of this day. We are also calling at the beginning of our science exhibition. Be with us as each of participants try to do his and her best. May you bless each of them to do their explanation, exposition, and demonstration in a way that is really up to a science. O God our Father, we really rely on you, for there is no answer in the world without you. The pandemic time that we are going through has no answer, the beginning of it and the end of it. So we are really relying on you to end this pandemic time so that we can go back to our normal life. As we hold this exhibition, enlighten each one of us with your knowledge, with your wisdom. We make this prayer your almighty power. Amen.
Thank you so much, Father, for leading us into prayer. Words can motivate mountains. There is synergic power in every word. Words can motivate people to action and make a difference to their lives. I request Father Rector, Reverend Father Thomas Gomes, to deliver his words of wisdom.
Well, my dear participants in this science exhibition, I have already said at the beginning, as I started this prayer, with a quotation of Albert Einstein, who said that a science without religion is like a lame man without a crutch. That is very self-explanatory. Needs no explanation, and we can all understand it. We are actually grip of the power of Almighty existence. We believe in Almighty God because the world, the universe, still a mystery to us. Our own existence, day in and day out, gives us a question, so big a question, that where do we come from, where do we go, and we find no answer. Several things comes about, science gives its own answers, religion comes with its own answers, every aspect of knowledge comes with its own answer, but God Almighty is God. To Him to understand is need another really enlightenment from God Himself to us. May our life, though is very scientific and technology minded and living to a revolution which is completely different, we pray to the Almighty that His existence for us and making us what He wants us to be, that we may not deviate His power and His knowledge and His might. That we may always be really reverential, fear to Him, and be a reverence to Him, and really give our respect, our love, our worship, our homage to Him, that we may always understand that it is He who leads us, that it is He who guides us. May our own knowledge may not lead us to pride. There are certain people who goes beyond God. They think more themselves God than the God Himself. So we would ask that we may not go beyond, because of our little knowledge, try to go beyond God. I wish you all the best at this science exhibition. Try your level best to explain, to demonstrate, and to enlighten us with your exhibits. Thank you so much.
Thank you so much, Father, for your heartwarming words. May I now request our principal, Reverend Father Manoj Jose, to inspire with his words of motivation and thus make a difference in our lives.
A very good morning to each of you. Reverend Father Rector, respected Sambutta Misra, Chief Guest of the Day, respected teachers and my dear students. At the very outset itself, I would like to wish you a very happy and prosperous New Year 2022. I place on record my heartfelt gratitude, thanks to each and every teacher of our science department. Through the efforts made by you, this event is made possible. Dear students, our aim is to encourage innovation among all our students, as you are the future of our nation. I'm sure that you have put in a lot of hard work, displayed commitment and dedication to ensure a smooth sail. I do appreciate and congratulate the science department comprising of both staff and students for this novel idea of having the first ever online science exhibition in the history of DBL. I express my gratitude to Mr. Sambutta Misra for honoring our invitation to be the chief guest on this occasion. In spite of your busy schedule, sir, you have joined us. You've given your time to be with us. Thank you very much, and may God bless you for your generosity. Someone has rightly said, men love to wonder, and that is a seed of science. Men love to wonder, to think, to cogitate, to ponder, to meditate, and there lies the seed of science. Dear students, here is an opportunity for you to wonder, to meditate, to reflect, to think, so that fruits and seeds of science can grow. I wish you all a great time, a learning time, and may God bless our endeavors. Thank you very much.
Thank you so much, Father, for your words of wisdom. We now have a video accommodating some famous scientists with their popular works. Let's sit back and enjoy the video presentation. Now, I would request Sir George Sarkar to introduce our chief guest for the day.
Isotope geochemist at the Center for Earth Sciences, Indian Institute of Science, Bangalore. A master of mass spectroscopy who loves forums, hates fieldwork, opinions are my own. As quoted from Sir's very own Twitter bio, is testament to his invaluable work. It's our immense pleasure to welcome amidst us the chief guest of the day, Dr. Shombuddha Mishra. We highly appreciate your presence in the event, sir. He is presently working as an honorary faculty at Center for Earth Sciences in IISc Bangalore. He graduated in chemistry from St. Xavier's College, Kolkata, and did his master's in marine science from Calcutta University. He further continued his studies in Florida State University, from where he obtained his PhD in chemical oceanography. He continued as a postdoctoral fellow in Florida State University. He worked as a postdoctoral fellow even in Cambridge University. He was also crowned with a lot of awards, both in India and abroad, like the Newton Trust Postdoctoral Fellowship Award from the University of Cambridge. Recently, he was adorned with one more prestigious award, the Swarnajyoti Fellowship in 2020 from the Department of Science and Technology. He has made remarkable contributions in the field of science, which is evident from his more than 30 research papers published in different journals throughout the world. We are highly privileged to have you in our midst, sir. Thank you.
Thank you, George. Thank you, Father Rector. And thank you, Aryan. And let's get started with the short presentation that I have made for you guys. I hope the screen is visible.
Yes, sir.
Perfect. Let me turn my video off for the moment, if it's possible. Okay, cool. Now, you guys quoted Einstein when you started this science exhibition by saying that there are two things that are infinite, the universe and human stupidity. And I'm not sure about the latter, and it's one of my favorite quotes. And I was very happy that this is how you guys are looking into the world of science or world of philosophy, as we call it. And then Father pointed out that science without religion is kind of a directionless entity. Now, life, as we know, has two ways to be explained. One is the pure, dry scientific way that some molecules came together to form a system which can reproduce itself. And then we can think about the divine intervention, that it was created by some Almighty. Now, whatever be the source of life, the fact remains that life on this particular planet, and we are not sure if there is life outside of this particular planet, the idea that there is no life outside of this planet is quite, I would say, exciting and depressing at the same time. And whereas the idea that there is life outside of this planet is both thought-provoking and fearful. What if they are the kind that we don't want to interact with? Now, having said that, the life on this particular planet is at the mercy of the geology of the planet. And what I'm going to show you is that in the last 500 million years since the existence of the planet, which formed around 4.5 billion years ago during the solar synthesis, there have been 5 major incidents when life has been wiped off from the surface of the planet. By wiped off, I mean almost 99% of all living beings were killed off by certain activities, part of which is happening from what we call the core of the planet. Now, to get into the details of it, we first need to understand the heat budget of the planet. Much of the heat that we received comes from the sun, and it's around 180,000 terawatts. And those of you in senior classes of high school know what watt stands for. Now, there is a small amount of internal heat coming to the surface of the planet, which is around 43 terawatts. And this is all due to radioactive decay of heavy elements. And this is coming straight from Marie Curie's work, that all of the radioactive decay processes have certain amount of energy associated with it. Now, it's essentially like leaving a burning coal at the surface of the planet, or if you bury it very deep, what happens is the heat is retained for a longer period of time if that burning coal is buried at a depth. Now, the problem with a burning coal is that you need oxygen to burn it. As long as oxygen is there, it will keep burning, otherwise it will stop burning. However, with radioactive systems, we don't have that problem. The decay system happens irrespective of its condition around it. So we have some heat coming from the surface of depth of the planet. Now, if we look at the entire history of the planet, our existence is for around 4.5 billion years. The universe, as we know it, from the Big Bang Theory onwards, have existed for around 13.7 billion years. And our solar system has existed for around 4.5 billion years. Now, if we squeeze the entire time of Earth's existence into a 12-hour face of a clock, this is how it would look like. First is the formation of the moon, which happened within 100 million years of the formation of the Earth, not much longer after that. Beyond that, what we call happened is the heavy bombardment, where a lot of meteorites fell on the planet. Photosynthesis started long time ago, around 3.5 billion years ago, and it took life almost 1 billion years to oxidize the atmosphere. By oxidize the atmosphere, I mean formation of an ozone layer, which kind of protected us from the harmful ultraviolet rays. And then the complex life form that we know of evolved at around 500 million years ago. So almost 4 billion years of Earth's history is kind of barren. It's like building up the foundation on which life has thrived. Slowly and very slowly oxidizing the surface of the planet, because much of the planet is a reduced environment. So you have to oxidize it to have free oxygen. Now, the moon formation was a very violent event. A Mars-sized planet came and collided with Earth, causing a disk of debris, which is at extreme high temperature, to be formed around the planet Earth. So in the sequential events, this is how the moon formation happened. When the collision happened, we formed a disk-like structure around planet Earth. And this disk started to accumulate enough mass, thus enough gravity, so a much more larger and solidified piece of moon was formed eventually. So the initial history of the planet was very violent. Existence of life is impossible in that period of time, because the temperatures, as you can see, were in hundreds and close to thousands of Kelvin. Okay. Now comes what exactly happens in our planet. Let me start this one. Now comes what exactly happens to our planet. Any meteorite impact that we can have will lead to large-scale destruction of life, large-scale destruction of planetary atmosphere. This is kind of a graphical representation of what happens when a meteorite impacts the planet. The first thing that you notice is the extreme high temperature that is caused at the point of impact. And that leads to essentially vaporization of rock. It might sound a very far-fetched idea that we are vaporizing rocks, but from all of these meteorite impact sites, what we can observe that there are tiny droplets of glasses strewn across hundreds and thousands of kilometers. How do you form droplets of glasses? You can only form droplets of glasses when you have a silica cloud, a cloud of molten glass, which is formed with these sort of high impact collisions. Because remember, a meteorite is usually traveling at 10 kilometers per second speed when it enters the Earth's atmosphere. One such impact happened around 66 million years ago, what we call the Chicxulub crater. And this is when the dinosaurs disappeared from the surface of the planet. If you want to understand the scale of this impact, the radius of this crater is 200 kilometers. Much of the crater is underwater. Some of it is on land, but most of it has become forested, so we don't see it much. Now, beyond this, there is one phenomenon which is ubiquitous on the surface of the planet. That is plate tectonics. And this plate tectonics, the movement of the continents, is driven by the heat which is being created or generated at the center of the planet through decay of radioactive isotopes. Now, how do we bring about this movement of the continents? We know we have a very hot metallic core in the middle of the planet. Now, outside of that metallic core, we have what we call the outer core, which is molten. Then we have the mantle, which is divided into the lower mantle and the upper mantle. Now, in the upper mantle, there is what we call convection. Convection, as we know, is movement of material due to a gradient of heat, density. Essentially, we are changing the density of the mantle material based on how much we are heating it or differentially heating it at the depths or losing the heat at the surface. Now, please keep in mind, the mantle, if you are asked, is it a solid or a liquid? Your answer should be that it's both. On a short time scale, it's a solid. If the mantle was liquid, we won't exist, everything will sink. But on a longer time scale, on a million-year time scale, it's a liquid. It's like a very, very viscous liquid, which is flowing extremely slowly. Now, we struggle with certain ideas that does what we call these convections are perceivable in human lifetime. Yes, they are. They are perceivable in human lifetime through the fact that whenever the mantle material reaches close to the core, it's heated up. And as it's heated up, it will slowly rise to the surface. And this is where we have the crust at the surface, and it will bifurcate. And this is when continents split apart, when the mantle plume rises to the surface and moves in a lateral direction. And a graphical representation of it will be like this. We are heating up the mantle material at the depth, and it's rising to the surface. The crust sometimes allows it to rise above it. And this is what we call is a volcanic activity. It can happen on the surface. It can happen under the ocean. And the material from the mantle will move along the surface of under the crust, because this is less dense than the crustal material. So it cannot easily break free. If it could easily break free, we will have volcanism all around the planet. Now, keep one thing in mind. This thing is moving very fast. But in reality, the speed at which things are moving are centimeters per year. At times, it is millimeters per year. So it's a very, very slow process. Now, all this leads to this movement of those plates across the globe. Now, this is a very simple representation of how the plates move. They rarely move in such a, I would call it, simplistic one-directional way. This is a much more scientific representation. We are looking right now at the opening up of the Atlantic Ocean. This is where your South America is separating from Africa, and this is the North American plate, this is the European plate. So you can see the direction of the motion can randomly change, and this is a function of the mantle convection. So we live on a planet which is highly, highly dynamic. And every time an ocean opens up, we have large-scale volcanic activity. And that large-scale volcanic activity can spew a lot of carbon dioxide to the atmosphere. And we have been studying that carbon dioxide is a greenhouse gas. A greenhouse gas is something which traps infrared radiation and leads to excess warming. Now, following on that footsteps, let's look at how the globe has been warming in the last 70 odd years. And this is nothing to do with natural warming. This is all human created. And as the temperatures are getting warmer and warmer, you can see that the globe is going from a mean annual temperature of around 13 degrees, 14 degrees Celsius to 15 degrees Celsius. You may argue that this is only a 1 degree Celsius rise in temperature. However, that 1 degree Celsius rise in temperature is enough to melt northern hemispheric ice caps and substantial amount of the Antarctic ice cap. Now, what is causing this warming? And are we driving ourselves towards an extinction process by making the globe uninhabitable in terms of temperature, in terms of precipitation? Now, this is probably the most important graph in your lifetime. This is a graph of time going from left to right in years and concentration of carbon dioxide in parts per million, which is volume by volume. We are looking at 10 to the power 6, a volume ratio in the atmosphere. And this is how the carbon dioxide has been going up across 1950s to modern day. This is known as the Keeling curve. Robert Keeling measured it at Hawaii, which is away from all direct human influence. It's in the middle of the ocean. And what you can see is this unusual sawtooth pattern. There is an annual rise and fall, an annual rise and fall. This annual fall is attributed to northern hemispheric spring, when there is blossoming of plants right after winter, and the growth of the plants, the growth of the new leaves, the biomass accumulates enough carbon to reduce the carbon dioxide concentration of the atmosphere. But in the fall season, the leaves are shed, and during the winter they don't decay, but post-winter, in early spring, they rapidly decay to again put the carbon dioxide back in the atmosphere. Now, if you look at the historical data, now we are going from around year 1700 to modern day. Historically, carbon dioxide levels was around 280 parts per million. And only with industrial revolution, we have driven the carbon dioxide up to 400 parts per million. The last time the carbon dioxide concentration of the planet was at 400 parts per million was 3 million years ago. And humans didn't exist at 3 million years ago. So we have to be very careful about how we look at this carbon footprint we have in total. Now, individual carbon footprint, or what we call the carbon usage, can make differences, but the big difference is in the global scale carbon difference. Now, what we saw is this carbon dioxide rise with time. And what is the direct implication of it is the drop in seawater pH, which is given by this blue curve. Again, time is going from 1958 to 2018. On the left-hand y-axis, which is giving the red lines, is carbon dioxide concentration. And on the right-hand y-axis, we have the pH of the surface ocean in the blue line. And what is observable that the pH, or the acidity of the ocean, is going up. pH is going down means acidity is going up. Why would that be the case? That is the case because carbon dioxide keeps dissolving in seawater rapidly. It's a reactive gas. It's just like you drinking a bottle of Thumbs Up or a Coca-Cola. When you open it, there is CO2 coming out of the system, because CO2 is being put under pressure and dissolved in that bottle of liquid. Now, as carbon dioxide dissolves, it forms carbonic acid, which dissociates to form this H plus ion. And the more H plus ion we form, the more acidic the solution becomes. So the effect of this carbon dioxide is becoming that the oceans are becoming acidic. So we have to be cognizant of the fact that human carbon emission is having a huge effect on the global climate. The only way we can take carbon dioxide out of the system in a natural process, except for growth of plants, is what we call chemical weathering, where the rock reacts with the carbon dioxide in presence of water to form a weathered product. If you walk down a cemetery, you can see that the headstones have been weathered away over hundreds of years. If it's a marble headstone, it has been weathered away more rapidly than a granite headstone. So different rocks weather differently, and in the process, consume the carbon dioxide. But what I'm going to leave you with is this figure. This figure showing that historically, since we have started measuring temperature of the globe, and we have a record of carbon dioxide of the globe, how our activity has changed the carbon dioxide concentration and global temperature, driving us, not driving the humans per se, driving so many species towards extinction. So we have to be responsible in our behavior, in understanding how we can change this, how we can capture carbon from the atmosphere, and how we can lead to formation of a world where such drastic climate events are not caused by humans. Okay, I'll stop here, and I would like to take some questions from everyone.
Yeah, if any participant has any queries, you can just raise your hand. We'll unmute you and you can ask your question. Thank you. Yes, Abhi, you can ask your question.
Sure.
Abhi,
Hello.
kindly unmute and ask your question.
Yes, sir. So my main doubt is that like dinosaurs went extinct due to these meteoric collisions. Is there any chance that these meteoric collisions can happen again? And if yes, what will be like the estimate amount of time? Can it happen in the near future?
It definitely can happen in the near future. And if we go back in time, this is what, can you see my screen still? Right?
Yes. Yes, sir.
So what we are looking at is the different mass extinction events on the planet. And what you can see is that in this particular one, the Permian and then the Permo-Triassic, it's a Triassic-Jurassic. Both these events is spewing of mantle material from the depth to the surface. But unusually, there are evidences of meteorite impact. Every 100 million years, between 100, well, I would say between 75 to 100 million years, there is a large meteorite impact. This is purely based on probability statistics, because given the number of large meteoritic bodies in the solar system and the frequency of collision that we can have with them, every 100 million year we have a high probability of a meteorite coming and colliding with us. So definitely it can happen.
Yeah, Tamosho, you can ask your question.
Yes, sir. Sir, my question is, sir, what is the meaning of TW, sir?
TW, where did you see it?
Sir, I see it in the external
Terawatts.
solar. Sir.
This is terawatts.
Yes, sir. Here, sir. So, what is terawatt?
What
is
is the unit of energy? Okay. So the amount of energy we are receiving from the sun annually is 180,000 terawatts, and internally it's only 43 terawatts.
Okay, sir. Okay, sir. Okay, sir.
Abnik, you can ask your question.
Yes, sir. So my question is that so we have known in many the scientists have made a probability that in the next million years, so the Andromeda galaxy and the Milky Way galaxy will collide. So is there any possibility of creating a new black hole or any kind of new planet in the new galaxy which will be formed?
The collision of galaxies, you got to understand one thing. Galaxies are 99%, it's like an atom. Most of the space is empty. Until and unless the black hole formation happens when a star collapses under its own gravity. Okay. Uh, Take, for example, our sun. Our sun is a star. And you might have heard this adage that we are nothing but stardust. So the sun or any star starts with burning of hydrogen, where two hydrogen atoms combine to form a helium atom, and so forth and so on. So you start getting to the heavier and the heavier elements. And beyond a certain point, it becomes so dense that it collapses under its own weight. And that's when black hole formation starts. Collision of galaxies, if you combine two such stars, two such large stars, you can lead to formation of a what you call a black hole. But again, it depends on the setting. If the right two bodies collide with each other with a given amount of time, it will. But there is no certainty of such things happening. Usually, black hole formation happens when a star burns all its fuel, not before that.
Himanshi, you can ask your question. Himanish.
Yes, sir. So your presentation told us about what happened over the past years. So recently there has been a political campaign, sir, net zero by 2050. So we know now the negative side, but what's the positive side? How do we fix this? Because according to the statistics, by 2050 it will be nearly impossible to set everything to zero.
It definitely will be impossible to set everything to zero. Fixing it, the scientific approach should be carbon capture. If we can't capture carbon in an energy efficient way out of the atmosphere, then we are causing like irreparable damage to the planet and climate change to the extent that we can't come back to the baseline, which was before the Industrial Revolution. Stopping emission is a good thing, but we have caused enough emission that there is a runaway warming effect, which is going to happen for the next 100,000 years. So stopping emission won't solve the problem in one go. We have to carbon capture. And that is where a lot of research is going on, how to draw the CO2 out of the atmosphere, either by increasing weathering or by, some say, plantation of forest, but forest can capture only small amount of carbon. So we need better technology for carbon capture.
Yes, Swapnindu, you can ask your question.
Good morning, sir. Sir, I had two questions.
Sure.
Firstly, what changed the Earth's atmosphere paved way for the rise of life on Earth?
It started with bacteria. The bacteria started synthesizing oxygen, and oxygen was actually a waste product, and it was toxic to them. It's very fascinating. Life on Earth went through a cycle, and we can look at it from banded iron formation in the oceans. What it means is that iron can only be in solution if it's reduced. Iron 2 plus stays in solution. Iron 3 plus don't stay in solution. It flocculates out. So the banded iron formation tells you that the early Earth, around 3 billion years ago, was going through a process of oxidation. It was again reduced. It was oxidized, reduced. So the banded iron formation gives us the first evidence that how bacteria over billions of years build up enough oxygen to oxidize the surface of the planet. And we really owe it to them that we exist, because without this layer of oxygen, not only can't we breathe, because an aerobic form of life will exist, but it's the UV radiation from the sun, we won't be able to stop it. And that will lead to a mass death at the surface of the planet. So it's the bacteria we have to thank for our existence. Next.
And so my second question was that what is a white hole? Are the black holes and white holes linked, or are they two different separate things?
That is a question. They are separate things. Do you mind writing me an email? Then I can send you some material to read. Because if I try to answer now, it will take another half an hour to answer. Okay. Send me an email. Okay. And I will definitely answer your question in that on the email.
Yes, Aditya, you can ask your question.
Yes, sir. I had the same question, sir. So, what is the difference between a black hole and a white hole?
Let us answer that with, I need to show you material to understand. See, black hole is when a star collapses under its own weight. Okay. White hole or white dwarfs are something very different. Okay. The ideal way to answer these questions will be by showing you videos of how these formations happen. I don't have it on this computer. I have it in my department computer. Send me an email. I'll get you on a Zoom link, and then I can show you what it exactly is. Okay.
Yes, Swapnil, you can ask your question.
Good morning, sir. Sir, I have the question. Sir, what are the prospects of making a career in geophysics after class 12? Like, how do we proceed in it?
There is so if you want to become a geophysicist, the first few things you have to know. One is good amount of physics, and one is good amount of geology. So you can join a good earth science program in any of the institutions. Like Jadavpur University has a very good earth science program. We have a very good earth science program. But you have to keep in mind that physics needs to be a big part of your curriculum, because most of the geophysics work is computational work and driven by physics. Like the idea of plate tectonics came from Rutherford's group, and his student Terry Bullard first proposed the idea, and then Dan Mackenzie came up with it. So it was completely through the physics stream that the idea came. So I would say go for a very good geology program, or try and get into programs where there is both geology and physics being taught together.
Yes, Arya, you can ask your question.
Yes, sir. Good morning, sir. Sir, my question was that I have heard that as the days go by, sun's gravitational force is increasing and it is attracting all the planets more and more as the days go by.
Not only that, the size of the sun is also increasing. Why? Because the sun started with burning hydrogen. Now, if you keep burning hydrogen, you will form helium. So your mass, the density of the system is going up. Okay, so that's for sure. So the more important fact is that the size of the planet, size of the star will increase. Around 5 billion years later, it will be so big that its diameter is going to be larger than the distance between the sun and the earth. So planet earth won't exist in around 5 billion years.
And sir, I have one more doubt that, sir, I have heard that M18 star is also collided host, means a host like sun.
You mean to say there is the M18 star, which is like the sun?
Yes, sir.
There are a large host of stars which can act like our own sun. Our sun is actually a very small star, one of the smallest stars in the observable galaxy that we have. And we study these stars because we want to look at exoplanets. Exoplanets are planets which we can inhabit.
Yes.
And the criteria of an exoplanet is that its distance from its star should be such that the surface temperature can hold liquid water. So that's what we call the Goldilocks zone. It depends on the luminosity of the star and the distance. And in the Goldilocks zone, even if you're in the Goldilocks zone, you need plate tectonics on the planet. Why plate tectonics? Because you need to constantly bring material from the depth to the surface for the surface to remain habitable for millions and billions of years. Unlike, it will be like Mars. There was probably liquid water on the surface of the planet, but since there is no plate tectonics, there is no recirculation of material, everything disappeared from the surface of the planet. Okay?
Thank you, sir.
Thank you.
Yes, Tiash, you can ask your question.
Excuse me, sir. I had a doubt, sir. What is the Big Bang theory which you told about during the Wheel of Time?
Big Bang theory is what we think how the universe came into existence. It's if you ask me what exactly it is, my honest answer to you will be even I don't know what exactly it is. Anybody who tells you what Big Bang is doesn't know what Big Bang is. Okay, there are very few people on Earth who can explain to you properly what Big Bang theory is. Ideally, in the beginning, there was only energy. And from the energy, mass and energy are interconvertible. And we produced mass in the form of protons. Protons are nothing but, if you take a hydrogen atom, if you take the electron out, you have a proton. So it's a soup of proton which exploded. And we know why there was an explosion, because we know that the universe is constantly expanding. And any expanding body will have its temperature going down because you have an initial for mass. And if you keep expanding it, its temperature has to go down. So we can calculate the rate of temperature lapse and say that there was a point from where everything exploded. And that is what the basis of Big Bang theory is. Does that answer your question?
Yes, sir. Sir, I would like to ask one more, sir, my last doubt.
Yeah.
Sir, what are the ways to reduce the carbon dioxide concentration in our atmosphere other than afforestation?
You can do afforestation. You can go for enhanced chemical weathering. What we do is we pulverize rock and we put CO2 rich brine in it. And the carbon dioxide will react with the rock to form another form of the rock and will be removed from the system. Then we can increase the productivity in the oceans. Keep in mind 60% of photosynthesis happens in the ocean, 60 to 70%. A very small percentage happens on land. So if we can fertilize the oceans, there are places in the oceans like the Southern Ocean towards the Antarctica where there is a lot of nutrient, but there is not much photosynthesis happening because there is not much iron in it. So absence of iron leads to a kind of a biologically dead ocean. So if we can fertilize the ocean, then we can draw down a lot of CO2.
Yes, Deepta, you can ask your question.
Good morning, sir. Sir, in your presentation, you mentioned that the oceans are getting more acidic. So how does it impact ocean life? And sir, I would also like to ask that in the near future, can it means the acidic level, can it rise to alarming levels where the ocean life will be impacted in a severe manner?
The pH has, in our lifetime, pH has dropped from 8.2 to 8.1. And you might think that this is not a big change, but it is a big change because the rate at which the pH has changed. In historical past, pH has changed by a larger amount, but those rates of change were very slow, happened over tens of thousands of years. At the moment, the problem we are facing is that things like coral reefs, okay, they are suffering due to this drop in pH. The primary producers in the surface of the ocean, they have their shell formed out of calcium carbonate. Now, as you lower the pH, they will struggle to form those shell. So the primary production level is going down. So that is one of the side effect of the drop in pH, the vulnerability of any organism that has a calcium carbonate shell. And most organisms in the ocean, most small organisms in the ocean has a calcium carbonate shell. The other part is the coral reefs because of the leaching. I wouldn't say bleaching. The bleaching of the coral reefs is more due to the rise in temperature than due to acidity. Corals are smart enough to modulate their internal chemistry. So they can still calcify, but what they can't do is stop other species from invading if the temperature goes up. So ocean acidification, let's be honest, is not as drastic as people make it out to be. But the main problem lies in the temperature rise, where the diversity of the species is changing. Make sense?
Yes, sir. Thank you.
Thank you.
Yeah, Utkarsh, you can ask your question.
Yes, good morning, sir. Sir, my question is there any true evidence of time travel?
No, it's one of those things that you can theoretically propose, but I don't think it's possible.
Siddin, you can ask your question.
Yes, sir, I'm telling that I want to become a scientist, means astronaut. So what I have to do?
You need to study one of the major branches of science, either physics, chemistry, maths, or geology, and then proceed accordingly. Get your undergraduate done, and then slowly different avenues can open up to you. You can do a PhD in any of these fields and related to earth sciences, so or planetary sciences or cosmochemistry. So eventually you'll have to do a PhD. So stay in science, study science first, and then see how your interests develop.
Your question, Saik. Arush, you can ask your question.
Sir, I had a doubt. We know that water covers almost 71% of the Earth's surface, but from where did all this water come from?
So initially, if you see, the planet was really, really hot, right? Whatever water we had, most of it left the planet. Once the planet cooled down, once we got to the stage where it was not boiling anymore, there is a heavy bombardment of, if you look at this part, we have the late heavy bombardment, right? And this is where you had a lot of these comets coming in with their icy comets. So we derived most of our water from icy comets.
Aditya, you can ask a question.
Yes, sir. Sir, I wanted to ask that who gave the Big Bang theory?
See, the theory was in what do you call it? The idea was there. The idea came from the fact that there is a red shift in the light coming from distant stars, because stars are moving away from each other. So which means the universe is expanding. So that Hubble was one of the first person to observe that. You have heard of the Hubble telescope, and this is known as Hubble constant. And later on, um, I'm forgetting the name, the Cambridge physicist. I'm forgetting the name. Drop me an email, I'll answer that thing. Okay, Stephen Hawkins. Stephen Hawkins's famous work was on Big Bang Theory. But don't think that he suddenly came up with the idea. Starting from a lot of astronomical observations, the idea that the universe was expanding was already there. He simply took that expansive idea and put a point source to it. Okay?
Sandeep, you can ask your question.
Yes, sir. Sir, I want to say that, sir, can you move a little down, sir? Little. Sir, that life versus life versus yes, sir, life versus planet Earth. Sir, what is that? Can you say again, sir?
This one. This is giving you the different mass extinction events. So we start with the first one at around 500 million years ago. Let's take you through that. Then comes the second one, the late Devonian mass extinction event. The first mass extinction event, the Ordovician, if you look at it, you see that the globe kind of freezes over. Late Devonian, the globe freezes over. Permian, it's hot. Triassic, Jurassic, it's hot. Cretaceous, Tertiary, it's again hot. Okay. So either there is a complete freeze over of the planet, or there is enough toxicity through degassing of mantle CO2 that life cannot survive. For survival of life, you need liquid water and a breathable atmosphere. So if you change either, life cannot survive. Okay.
Yes, sir. Yes, sir. Yes, sir. Sir, I wasn't able to unmute, sir.
Yes, Abnik, you can ask your question.
Yes, sir. Sir, I have a question that, sir, as you had told that all the galaxies are empty and all, but sir, if in the near future, so the sun, we know that the sun size is increasing, and it will soon become a red star, which will take all the Milky Way galaxy. So, sir, is there any possibilities that humans can shift to any other galaxy other than Milky Way, because all the scientists have discovered any galaxy like that?
Well, we are in the process of it, right? And I wouldn't call it near future. I would say for that to happen in an appreciable way, we have around 4.5 billion years left. The possibility of a meteorite striking us in that time far outweighs than the fact that sun will go big enough to gobble up planet Earth. Okay. So our vulnerability is more towards an extraterrestrial strike at the moment than in the increase in the size of the sun. And definitely, we are looking at exoplanets for this singular reason, that we need a second habitable planet, so that if something catastrophic happens to this planet, and as you can see, it has happened multiple times to this planet, life as we know survives.
Abir, you can ask your question.
Yes, sir. Sir, actually, I have two questions. So, first one is, we all know that temperature is a big macroscopic illusion. There is nothing such as temperature in this entire world. But is gravity also a macroscopic illusion like that?
Why would you call temperature a macroscopic
So,
illusion?
because how would you define temperature? We would define temperature like change. We would define temperature as the change in the heat.
Heat content.
Yes, but there is nothing actually such as temperature, no.
Well, we have defined what is temperature, right? We define the unit of temperature. I wouldn't call it illusion. Illusions are for magicians. We scientists, we don't believe in illusions, right? Gravity, if you call gravity an illusion, gravity, the unit, what determines gravity is your mass. It's very simple, right? The more mass you have, the more gravity you have. Your size doesn't matter. If you take a 1 cubic centimeter of iron versus 1 cubic centimeter of uranium, 1 cubic centimeter of uranium has a higher mass and thus has a higher gravity. Okay, so gravity is purely a function of mass. Temperature is purely a function of heat content. And then comes the question that given X amount of heat, does all bodies go up to the same temperature? That doesn't happen because the heat is transmitted to molecular vibration. The faster the molecular vibration, higher the temperature. Okay, so I would strongly recommend that you don't think temperature as an illusion. There is scientific explanation behind why if you put what do you call it? Uh, Different bodies heat up differently given the same amount of heat. Okay, so it's nothing. It's no illusion. It's pure physics.
Okay, sir, and so one more thing. We know that life is always able to mutate and adapt to the conditions. So then we can expose ourselves to some harsh conditions and possibly the future life or the future humans will be able to adapt.
Most definitely, you
and
can. But if it's that
like this
responsible,
coronavirus.
Coronavirus is a different thing. Coronavirus is mutating. Any virus would mutate to become more virulent and less fatal because the purpose of life is to reproduce, right? So if my host is always dying, I am not reproducing. If like the Ebola outbreaks are restricted to very small sections because everybody dies. So Ebola virus is not a widespread threat. Okay. But any virus or any organism wants to have the capability of reproducing. So if you have a host to reproduce in, you want it to survive so that more people are infected. Okay. So that's kind of self-selection in the process. And you talked about mutation. Mutation happens over millions of years. And any of these catastrophic events happens over less than a year, tens of years, or maybe hundreds of years. It's not enough time for mutation. Coronavirus is mutating because it's going through so many hosts.
Sayak, please ask the question.
Sir, my question is that as far all of the stars discovered by humans, which star is the biggest and which star is the smallest?
That I can't answer from the top of my head, I'll be honest with you, because the names are always changing, right? When I was a student, what was the biggest star discovered and the smallest star discovered is no longer the case, because we have been able to observe a larger part of our Milky Way with every passing year. So if you drop me an email, I'll look it up and definitely answer your question.
Okay, sir. Thank you, sir.
Thank you.
Yes, Aram, you can ask your question.
Yes, sir. Actually, I also have two questions. So my first question is that you said that moon was a planet that collided with the Earth. So, sir, sun's gravity will hold the moon in one place. How can it move here and there?
if that be the logic, then why do you have comets and meteorites?
Sir,
So in the solar system, there are, in the solar system, we are talking about the early solar system. We are not talking about the solar system as we know it now, right? So there were motions which are not it took almost 100 million years for the solar system to come to its present form of movement. Okay. And before that, there were large collisions happening all throughout the solar system because things were coming into equilibrium.
Okay, sir. So my second question is that, sir, you said that tectonic plates move here and move on the surface of the earth. Sir, are they moving now? And sir, in the future, where there will be only small parts of lands everywhere scattered.
No, land mass, the amount of land that you have exposed above sea level is a function of sea level. Usually the amount of continental crust doesn't change much. When you collide and form a mountain, yes, the available surface area reduces somewhat because there is a mountain formation. But other than that, it doesn't happen. You won't change the amount of land mass quickly. If you look at the videos of plate tectonics, what you can see is they're just like breaking apart and colliding and doing stuff like that. They are not being destroyed. For destruction, you need subduction. And continental crust is floating on the mantle, right? It's not being sucked into the mantle. So whenever two continental crusts collide, you have a mountain formation rather than one going into the other. Oceanic crust is denser than the continental crust, so oceanic crust will go under. George, I will have to leave because I have a class which should have started at 10. So is that okay?
Okay, sir. It's absolutely fine.
Sure.
Okay. Aryan, please conclude.
Yes, sir. Thank you very much, sir, for taking out your time from your busy schedule and enriching us in the science stream. Thank you very much, sir.
Thank you very much. It was a pleasure. Yeah.
Thank you, sir. With this, we come to the end of our opening ceremony. I wish you all success in today's and tomorrow's endeavor. May we all live up to and fructify our motto, Oceanus Cognitionis. All the best to all the participants once again as Science Exhibition 2022 unfolds. Tomorrow at 2 p.m., we have to join a talk show by Dr. Dbs Science, Director of Birla Planetarium, after which the names of the winners will be announced. So all the participants have to be present in the meeting at 2 p.m. Thank you. Bye.